All right. So I guess one thing I do want to quickly mention on the exam is that when you find a solution interval, that was I'll just pick number 1 for example. For example, at the end you got a solution. Y of x is equal to e to the minus x, maybe times 3 cosine 3x, and then the second term is 5 e to the negative x sine 3x. And it asks you for the solution interval. You just look at the sine function, the cosine function, and the exponential function. For those functions, you can put any number for x. So the solution interval is from negative infinity to positive infinity. And then you probably think, oh, is it the whole interval or maybe only part of it? Well, you look at the initial condition, y of 0 equals 3, x equals 0 is already included in there. So you don't need to split the interval into sections, just take the entire part. Includes x equals 0. So that's the solution interval. And I believe for the second one, it's the same thing. The solution interval is already numbers. Any questions? If you have any questions about the grading, again, feel free to send Professor Gibson an email with the picture of your exam, of your work, and see if it's going to be nice enough to give you more points back. All right. For today, we're just going to look at a couple examples about solving non-homogeneous differential equations. So non-homogeneous differential equation, ordinary differential equation. In particular, we are looking at examples of second-order linear non-constant coefficient, constant coefficient. It's just not homogeneous, and that has the differential equation has the form of ay double prime plus by prime plus cy equals f of x, and this non-zero term f of x makes it non-homogeneous. If f of x equals 0, then it's homogeneous. We know how to solve it. In fact, we do have to solve the homogeneous equation in the process. So this equation has a general solution. Y general has it's a sum of the homogeneous solution plus a particular solution. And how do we find the homogeneous solution? So the first step to find homogeneous solution, what we're going to do is that we're going to write down the homogeneous differential equation. Ay double prime plus by prime plus cy equals 0. And then from there, we should be able to solve this equation by using the solution ansatz that we have been using for the last week and a half. Y equals e to the lambda x. And that will give us a characteristic equation, 2 lambda values, or maybe just one repeated, or maybe give us complex values. But we should be able to figure out a solution. We're going to call that homogeneous solution. It's C1 e to the lambda 1x plus C2 e to the lambda 2x. I'm just writing down the distinct roots case. If you have complex roots, you're going to get something similar, or maybe you use cosine and sine. If you have repeated roots, one of them will have an x in front of it. But that's kind of the distinct roots case. So after we find the homogeneous solution, we're just going to put it aside. Don't worry about it now. And then the second step, to find the particular solution, we're going to use this method called Undetermined Coefficients. Which involves guessing a particular solution based on f of x. So we're going to guess the form of the particular solution based on f of x. There's a few common cases for f of x. I'm just going to make a list here. It's probably in the book. Also, if you look at online, you should find them. So if f of x is a constant, for example, we might have 5 on the right-hand side of the given equation. That's a constant. In that case, we're going to guess the particular solution just to be a constant a. Let me write down, for example, 5. Maybe I shouldn't use the example. Let's just see alpha, for example. So that's what we're going to get the particular solution to be. Now, what if f of x is a number times x? Or maybe a number times x plus another constant. It's linear. So let's see, it's alpha x plus beta. Doesn't have to have beta there. It could be just a number times x. If that's the case, we're going to get the particular solution to be ax plus b. And I should note that a and b and the particular solution that we guessed are undetermined coefficients. And we have to find them in order to find the particular solution. If f of x is quadratic, for example, it's alpha x squared plus beta x plus gamma. I'm just using random letters to represent some constant coefficients there. In that case, we're just going to get the particular solution to be ax squared plus capital Bx plus c. If we have a higher power of x, for example, x to the fifth, we're going to follow the pattern, but when we get the particular solution, we have to list all the terms of x. We can't skip any of them. So that's just something to remember there. Now, what if we have an exponential term, like an e to the alpha x, for example? That might be a constant in front of it, like c1 e to the alpha x, right? Doesn't matter what c1 is. And in that case, we're just going to guess the particular solution to be a e to the alpha x. And the one last one, if we have f of x to be cosine omega x and or sine omega x. It doesn't have to have both in f of x, it may be just one of them. Just cosine or maybe just sine. In that case, we're going to have to guess a particular solution to be a cosine omega x plus b sine omega x. So that's a case that we have to include both sine and cosine. But for the other cases, we just kind of write down what the form looks like with the constant ABC. There's a lot to take in. I personally, it's definitely helpful if you kind of memorize, but at least just try to look at, compare them. If f of x is a constant, then the particular solution will be a constant. If f of x is a linear function, the particular solution will be linear, basically. Now, note couple things. If f of x is a sum, or perhaps a product of this form that I listed above, of those cases, of above cases, then we're going to guess the y particular to be a sum or product of above forms. But what does that mean? That, for example, f of x is the product of exponential and the cosine. Let's just say f of x equals e to the alpha x and the cosine omega x multiplied together. It could be a sum between them, but let's just say it's a product between those two different sums. In that case, when we guess the particular solution for the differential equation, that particular solution will be a product of this a e to the alpha x and then this sum. A e to the alpha x times a cosine omega x plus b sine omega x. And obviously there's a couple of issues with my notation. We wouldn't have a here and then a here because they might have different value, right? So you could say, okay, let's call it a1, call this a, the different. So that's one thing. A second thing is that we really don't need all three different coefficients, because this a1, if we distribute into this parentheses, so that will be a1 times a, that's a new, let me write down. So that will be e to the alpha x, a1 times the a, cosine omega x, plus a1 times b, sine omega x. As you can see that when we distribute the a1 into the parentheses, we really just have two different coefficients, not three. So we could just say, okay, instead of using a1 times a, we're just going to call this some a hat. This one we can call it b hat. So in this example, we really only have two coefficients that we don't know. But I just want to show you that if you have something like this, then the particular solution will be a product of what we listed above. And then that just really just e to the alpha x, a hat, or a tilde, cosine omega x, plus b tilde sine omega x. We still have only two coefficients, not three. So that's the first thing. We're going to see an example similar to this, not quite there. The second thing to note is that if in the particular solution that we guessed, the term in the particular solution matches with term in the homogeneous solution that we solved for before this guess. If that's the case, then we're just going to multiply the term that's same, multiply by x until they're different. Multiply term in particular solution by x until they're different. And what I mean by that is that, let's just say, we have some problem we solved, and we end up with y homogeneous is equal to c1 e to the 2x plus c2 e to the 5x, for example. And then when we guess the particular solution based on the right-hand side, we end up with the particular solution to be a e to the 5x. For example, that's just based on f of x. Right? We're not going to use this for particular solution because e to the 5x and the e to the 5x are the same. So what we're going to do instead is that we're going to multiply this by x. That will be different from what we have. So we're just going to use ax e to the 5x instead of e to the 5x to make sure that that's different from the homogeneous solution. And we're going to see example on that next time. That's just something to keep in mind. Not yp equals a e to the 5x. Because if we just pick this one, eventually that's going to be absorbed in here, and we don't have a particular solution. All right, so that's two things. Any questions? Oh, I'm not done yet. So the next step, after we guess the particular solution, we're going to substitute this particular solution into the original differential equation, solve for undetermined coefficients. And the step 4, obviously we have to write down the particular solution at the end and then write the general solution, which is the sum of y homogeneous plus yp particular. So there's a few things that we have to do. We have to find the homogeneous solution first. So we guess a particular solution, find it, and then put them together. It's probably a little bit confusing now, but let's look at some examples. And then hopefully that will clarify things. All right, the example I have is that we're going to solve this differential equation y double prime minus 4y prime minus 12y is equal to sine 2x. In this example, we have this right-hand side as not 0, right? It depends on what x is. Could be any number. So this is non-zero. Therefore, this equation is non-homogeneous. The left-hand side is linear, so all the terms are linear, and then constant coefficients. To find the solution, the first thing we're going to do is that we need to find the homogeneous solution, but we have to write down the homogeneous equation first, which is just replacing the sine 2x with a 0. So that's a y double prime minus 4y prime minus 12y equals 0. So this is the homogeneous equation coming from here. And we're going to solve it using the technique that we did before, using the ansatz e to the lambda x. I'm going to do a little bit quick because I think at this point you should be confident of finding the solution there. So I'm just going to do it quick. So y prime equals lambda e to the lambda x, y double prime equals lambda square e to the lambda x. If we take those derivatives and y put in this homogeneous equation, we should end up with a characteristic equation. That's going to equal to lambda squared minus 4 lambda minus 12 e, well, that's not the characteristic equation. That's just the equation when we substitute for y. E to the lambda x equals 0. The characteristic equation is lambda squared minus 4 lambda minus 12 equals 0. Okay. And then from here we can factor or use quadratic formula to find the lambda value. It turns out that we can factor this not too difficult. So that's going to be 2 times 6 is 12, so minus 6 positive 2. So lambda 1 equals 6, lambda 2 equals negative 2. The general solution for the homogeneous equation is what we call the y homogeneous, the homogeneous solution to the original equation. And that's going to equal to c1 e to the 6x plus c2 e to the negative 2x. That's a homogeneous solution. And after we found it, we just put it aside because we don't have to do anything with this until the end after we find the general solution. So leave it for now. Just don't forget it. Any questions? So that's a work we have done before, right? We just take the equation, make sure the right hand side is 0, make it homogeneous, solve. So the next one, we're going to guess the particular solution to the differential equation, the original one. It's going to equal to, based on the right hand side, we have what? We have sine 2x, the sine function. And earlier I had, if we have sine and the cosine, we can guess the particular solution to be a sum of those two trig functions. So that's what we're going to use. So we're going to guess that y particular is a cosine. So we have sine 2x, so cosine 2x plus b sine 2x. And then now what we're going to do, just like we did over here with the ansatz, we're going to put in the homogeneous, but this particular solution, we're going to put into the original differential equation. So we need to know the derivative, the second derivative. So y prime p is equal to, take the derivative, I'm going to do it a little bit quick here, so that's going to be, cosine is negative sine, so that's a negative 2a sine 2x plus sine is cosine, so 2b cosine 2x, and then take the second derivative of this particular solution. That's going to equal to negative 4a cosine 2x minus 4b sine 2x. And then we're going to put this into the given differential equation at the top. So we have y double prime minus 4y prime minus 12y equals sine 2x. So let's put in there. We have y double prime is negative 4a cosine 2x minus 4b sine 2x. That's a y double prime. Minus 4 times y prime, which is going to be negative 2a sine 2x minus 2b cosine 2x. And then minus 12y. So minus 12 times y, which is a cosine 2x plus b sine 2x. That's going to equal to the sine 2x on the other side. And then the next step is we're basically done with this differential equation process. We just have to expand this, combine like terms, try to figure out what a and b from here.
In the second term, plus 2b cosine.
Absolutely. Thank you. Yep. Right. So that's a positive. Good catch. Thank you. Right. So yeah. So that's a good point. If I'm not careful, I will make mistakes, right? Because sometimes you get multiple terms, so definitely try to be careful. If you want to solve problems like this, especially the signs, the negative, positive. So I'm just going to expand all the brackets. So that's going to be negative 4a cosine. I'm going to be a little bit lazy, just leave the parentheses the way it is without putting 2x in there. But you should know that all the parentheses has a 2x. Minus 4b sine minus plus 8a sine minus 8b cosine. And sometimes when I do problems like this, I don't even write down the parentheses. Obviously, it's not the most organized way with the work. It just saves time sometimes. Minus 12a cosine minus 12b sine equals sine 2x. And then what I do is I'm going to combine all the terms with sine, and then combine all the terms with cosine. So cosine I have negative 4a, negative 8b, and then minus 12a. So that's going to be negative 4a minus 8b minus 12a cosine. And then for the terms with sine, so we have negative 4b sine, positive 8a sine, and then negative 12b. And that's going to equal to sine 2x. I don't recommend writing with the empty parentheses on exams. If I'm reading, I know what you're talking about, but I'm misreading it. So I'll be for exams, I don't skip any details. So what do we have? Kind of one more step. We have negative 4a minus 12a, so that's a negative 16a minus 8b cosine 2x. And then we're going to add negative 4b, negative 12b, negative 16b plus 8a sine 2x. That's going to equal to sine 2x. At this point, we can look at both sides of the equation. On the left side, we have a cosine expression, and then we have a sine. But on the right side, we have a sine and then nothing else, right? So if both sides have to equal, then the term of the cosine must equal to the term of cosine on the right side, which is nothing. That means it's a 0 times cosine. So you can, assuming that there's a 0 times cosine 2x there, because it's not there. Then we can just say, okay, the coefficient of cosine here is 0, therefore the coefficient of cosine on the left-hand side must also be 0. We can write down the equation, negative 16a minus 8b must equal to 0. from the coefficients of cosine. And then we do the same thing with the coefficients of sine. We have here the coefficient of sine is, on the left side is negative 16b plus 8a, but on the right side, the coefficient is 1, is not written, but that's a 1 there. Those two expression must equal. So negative 16b plus 8a must equal to 1. At this point, we have those two equations, and we have two unknowns, a and b. We should be able to solve them. I'm not going to spend time finding them, but I'm just going to write down the answers. Double check, I think those are right for a and b. Good, excellent, thank you. So a and b are good. So now we found a and b. Remember, a and b are the coefficients in a particular solution, right? So now we can go back, take them, and to put them back into the particular solution that we guessed, replace a and b there, and write down the particular solution. So y particular is just going to be 1 over 40 cosine 2x minus 1 over 20 sine 2x. That's a particular solution. That's not the general solution for the differential equation. And then we have to write down the general solution, which is just going to be the product of the homogeneous solution and the particular solution. So that's going to be c1 e to the 6x plus c2 e to the negative 2x, and then plus a particular solution 1 over 40 cosine 2x minus 1 over 20 sine 2x. So that's the general solution at the end. It might look like it's a long process, but it's once you kind of figure out the key steps in the process, they kind of just follows naturally, because if you guess the solution on that for the homogeneous solution, then you kind of follow that through. Then you guess the particular solution, you follow that through at the end, add them together. And we still have those two that we don't know. But I want to point out that in the particular solution, there's no unknowns there, except for the x and the y. Because we begin with two unknowns, we solve for them already. So everything that is known, other than the variables. Any questions on this? I think differential equations is getting more interesting from this point, because the rest, there's more things that we have to learn, obviously, but you kind of get a feeling on this, on how to solve it from this point. All right, so the next example I have is y double prime plus 3y prime minus 28y is equal to e to the 5x plus 28x. Solve for the general solution. So the first thing we have to do, we have to find the homogeneous solution. So to find homogeneous solution, we're going to begin with the homogeneous equation by setting the right-hand side equals 0. Y double prime plus 3y prime minus 28y equals 0, and then we can solve for it from here. Let's see. Is it okay if I don't show the work? Okay, you can try to find it on your own quickly. Maybe I'll give you 2 minutes, perhaps. So go ahead, take 2 minutes, find the homogeneous solution at the end. So lambda 1 is -7, lambda 2 is 4, so C1 e to the -7x plus C2 e to the 4x. That's a homogeneous solution. And then the next step is to guess the form of the particular solution. Now, if you just look at the right-hand side together, e to the 5x plus 28x, that's not one of the terms that I listed, right? But it's a combination. So e to the 5x plus 28x looks like that's this term and the linear term together, right? So therefore, the particular solution will be this expression plus this one. So note, e to the 5x will give us a particular solution a e to the 5x, and the 28x will give us a particular solution ax plus b. Because they're adding together, so the particular solution will have those two expressions added. I'm not going to use 2a's because we need to distinguish the coefficients. So maybe we're going to say it's a e to the 5x plus, instead of a again, we can say bx plus c, or dx plus b, whichever you, does it really matter what you use for this ABC? A lot of times, in my experience, when I solve a positive differential equation, we might have multiple, like maybe 4 different unknowns. Instead of calling A, B, C, D, we just call it A1, B1, A1, A2, A3, or something like that. So as long as you know what they refer to, you can basically call them anything. And then what we're going to do is that we need to know the derivatives so we can plug into the differential equation. So y prime of this particular solution, just take the derivative. That will give us 5a e to the 5x plus the derivative of bx plus c, just give me a b. C will become a 0 when we differentiate. And then we take the derivative again. The second derivative of this particular solution would be 25a e to the 5x plus nothing, just 20, that's it, right? The b will go away, become a 0. Now we have this derivatives we can put into the differential equation. So that's going to give us 25a e to the 5x. That's the second derivative, plus 3 times the first derivative, that's 3 times 5a e to the 5x, plus b, and then minus 28y will be a e to the 5x plus bx plus c. And that should equal to e to the 5x plus 28x. And I'm going to expand this left side, just like what I did before, and then try to combine the terms. So that's going to be, I'm just going to do it a bit quick here, so that's a 25a e to the 5x plus 15a e to the 5x plus 3b minus 28a e to the 5x minus 28b x minus 28c. That's going to equal to e to the 5x plus 28. And then I'm going to group the left side based on the factor e to the 5x, x, and then constant terms. So if I do that, I have 25a plus 15a minus 28a e to the 5x. And then the term with x, it's just only one term, so negative 28 bx. And then the term with constants, so that's 3b negative 28c. I'm going to put them together. Oh, I forgot an x on the right-hand side. So that should equal to e to the 5x plus 28x. And then to find ABC, what we're going to do, again, we're just going to look at the coefficients of each term. The e to the 5x has this as a coefficient. It turns out to be, if we kind of do it quickly in our head, right, we have 25 plus 15 minus 28, that's about 12a. And then here we don't have, we just have 1 times e to the 5x, so they should equal. So let me note that this part, if we kind of do it, simplify, that's going to be 12a. So that 12a as a coefficient should equal to this 1 as a coefficient on this side. So we have 12a equals 1. Then we look at the terms with x. On the left side we have the coefficient negative 28b. On the right side we have positive 28. So those two values should equal. So negative 28b should equal to positive 28. And then the last thing we have to look at is the constant term. On the left side we have 3b minus 28c, that's a constant. On the right side we don't have a constant, it's a 0. So we can set those two equal. So 3b minus 28c equals 0. And then we can solve for ABC from there. So A, B, C. 1 over 12, B is negative 1, C is negative 3 over 28. It was something like that. Double check. Good. Thank you. Excellent. So that's it, right? So at the end, we can write down the particular solution. So just plugging ABC that we found. So that's a 1 over 12 e to the 5x minus 1 times x minus x, and then plus a constant, so that's a minus 3 over 28. This is a particular solution, and don't forget to put it together with a homogeneous solution. So y general equals y homogeneous plus y particular. So that's a C1 e to the negative 7x plus C2 e to the 4x, and then those terms from the particular solution. Questions? I do want to point out one thing that you could check to make sure that your work is correct, especially after you plug in the derivatives of a particular solution into the differential equation, is that if the particular solution has 3 unknowns, then you should end up with 3 equations at the end. And another thing you could use is that those 3 equations shouldn't give you different values. For example, this one gives you A, this one gives you B, that gives you C. You shouldn't have you shouldn't have 2 equations give you 2 different values for the same variable. If you have B equals -1 from here, then you have B equals +1 from the last equation, then you know you did something wrong. So that's something to check. Which shouldn't happen, but it might. If that's the case, then you know that you had a mistake somewhere in the middle. You have to go back, make sure all the expansion is correct. All right, I'm done talking. I'll see you on Thursday. Take care.